Hi everyone, my name is Tyron Johnson. I'm a solutions engineer at Precision Optical Technologies. I'm going to do a quick 10-minute overview of the 100G-ZR pluggable transceiver. So one of the first things I wanted to highlight is that it's a full C-band tunable in a QSFP28 form factor, and that's obviously quite a common form factor in a lot of 100G routers and switches. There's two versions. There's the -8 TX launch power and the 0dB launch power, and they both can do 100G Ethernet or the 024 data rate as well. Both can operate on a 50 gigahertz or a 100 gigahertz I2 grid. So that's your 96 channels or your 48 channels. Looking at the one on the left, the -8, it has an unamplified optical budget of 22 dB, and the one on the right, the 0dB, has an optical power budget of 30 dB. They can be amplified as well, so if you do want to put them over an optical line system with a dispersion compensation module, it can reach up to 300 kilometers depending on your OSNR. They both use DP-QPSK modulation, so it's a coherent optic. And the -8 operates maximum power consumption of 5.5 watts, and then the 0dB at 6 watts. So some of the main applications are point-to-point unamplified, so not running through a multiplexer, -8 80 kilometers, and then 0dB 120 kilometers. And then if you do want to put them through a MUX-DMUX, which you probably will do because it's a C-band DWDM, it depends on your insertion loss of your multiplexers, so running between something 40 to 80 kilometers. And then again, if you do want to amplify them, up to 300 kilometers, depending on your network design and OSNR. They can also run alongside brownfield applications, so if you want to add additional 100 gig waves. Probably would recommend the 0dB for that, especially if it's going into ROADMs. Probably the most use case for it is access, because we believe we expect that 80 kilometers will cover up to 90% of most use cases. So there's quite a lot of customization with this product. First of all is the management interface, so where you've got to select CMIS, which is Common Management Interface Specification, or SFF 8636, which is your MSA. Decide whether you want to use the -8 or the 0dB TX power. Then you've got your 100 gig Ethernet or your 024. The environment it's going into, so your 0 to 70 degrees commercial temperature, or your -40 to +85 industrial temperature. The chromatic dispersion setting is actually something that you can do on the transceiver itself, so both the hardware kind of defaults to that. And then whether you want to CLI tune them, so manually tune them yourself, that could either be via the external coding box that we offer, or actually on the command line interface of the host platform. And then there's also the alternative auto tune, so that's a smart tune MSA, so it will scan through all the channels that's available on the MUX and then lock in that channel. And then if you do want to do some sort of colorless ROADM application, you have the option to add the tunable optical filter as well on the 0dB version. So going into the Common Management Interface Specification, so this is probably likely the choice for most network equipment manufacturers because it allows you to select the wavelength via the command line interface, and then also select your application, whether that be the chromatic dispersion settings, amplified or unamplified. And it also allows you to see some advanced monitoring parameters, so your versatile DOM monitoring, so chromatic dispersion, your optical signal noise ratio, and your differential group delay. So that's all important parameters that you need to see on a coherent type optic. So obviously the pros are that you can do remote features, so you can CLI tune them or via the GUI or the CLI. But the current issue at the moment is that a lot of network manufacturers don't have the support for CMIS. So it's either going to be a new platform release or some sort of update. It's still kind of being solved at the moment. So it's quite limited platforms. So if you don't have a CMIS platform, which most won't at this point, you can go down the 8636 route. And this basically means that if you've ever used 100G LR4s or any kind of QSFP28 form factor, it uses SFF8636 already. And that basically allows you to get your standard DOM parameters, so your temperature, your TX and RX power values, laser bias, voltage. It's pretty standard stuff. But the problem here is that you won't have the option to CLI tune the transceiver via the host. So we're going to have to add in an external tunable option. That can be done via an evaluation board or a tune-in box. So the pro of this is that pretty much most router and switch out there currently uses MSA. So it will go, as long as you have a QSFP28 port that can support up to 6 or 5.5 watts, you're pretty much good to go. You're just going to have limiting monitoring parameters, and then it won't recognize as a true 100G-ZR because the network equipment manufacturers haven't implemented that yet. So this is just an example of the external tune. It's basically got a slider. You would plug in the module into the coding box or the tuning box, slide it along, press tune, and then it will set the wavelength, and then you would plug it into your host platform. So the alternative solutions to the 100G-ZR currently is your traditional transport system, but obviously the overall cost and the power consumption is pretty high. You need specialists to install it, usually by the network equipment manufacturers. Installation time is quite long as well. And then you have the expensive CFP2 DCO, which is 100 and 200 gig, but you still have that similar problem. And then probably the closest one to the 100G-ZR is the PAM4 version, because it is QSFP28. But you need some sort of external amplification and dispersion compensation to even reach above 10 kilometers, really. And then the non-DWDM options are your traditional 100G-ZR4 gray and 100G BiDi, so single fiber working. And then the 400G coherent ZR module, but you would downrate that to 100 gig, so you're basically wasting a lot of your data. So that was my slides. Are there any questions?
Yep, we've got a question for Will at the back there.
Hi, it's Will Hargrave from LonApp. I have a question about, you were talking about the two different methods of managing these optics.
Yep.
Just thinking about kind of, they would have a long time in your network. So is this a thing you select at ordering time, whether you use SFF8636 and go on or CMIS, or what will the future be, basically?
Yeah, you would know that. So you would know if your host platform supports CMIS or whether it doesn't, basically. So your network equipment manufacturer will tell you if it supports CMIS. They will be releasing their own versions as well. So ours is kind of like a drop-in replacement for that CMIS module. But the MSA version is if it's existing platforms, really. So
yeah, so there wouldn't be like an option to like recode the transceiver later to make it use CMIS?
You can, but it's a firmware change.
Sure.
And you would have to send it back to us to do that.
Okay.
Yeah.
Well, my platform can reprogram optics, but it's a bit scary.
Yeah, okay.
Thanks.
Any other questions?
Is a bidirectional version on the horizon as well?
Good question. It's quite difficult to do bidirectional with coherent optics. I would say so, because they are doing it with CFP2 DCOs, but I don't think the technology is there right now. I'll probably say within five years, something along them lines.
Okay. Excellent. Well, thank you very much, Tyrone.
Thank you.